Hi, this is my lab number one about constant velocity for Physics 2211. So let's get started. Yay! To understand our lab and its experiment, we need to first understand its purpose, which in this case is learning more about Newton's second law. We are going to be doing this by analyzing the motion of an object, which in our case is going to be a ball, that is going to be moving at the same speed without changing direction. We are going to be further exploring this concept by making a computational model and comparing our object's observed position with the predicted position made by this computational model. So, the key concept that we need to be familiarized with is Newton's second law, which basically states that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to its mass. Some other concepts that we should be familiarized with is net force, which is the overall force acting on an object, and velocity, which is the rate of change of an object's position in a specific direction. Here is an illustration with some formulas that are relevant to the experiment that we are going to be making. As you can see, we are considering time, location, mass, and velocity. Moving on to our experiment, here is the original video that we are going to be using for the observational analysis. To perform this video analysis, we used a motion tracker that allowed us to plot the position of our ball over time. We should also note that in this case, we set the axis in a way that the starting position of our ball is set to 0. We also should note that in this case, the system is our ball, the surroundings are the table, the doggo, and everything else. And we should also assume that there is no friction and the net force is of 0. Based on the information that we gathered from the motion tracker, the next step in our experiment was to generate the computational model. The key things to note from this was the mass, that was 0.056 kilograms, the velocity, which was 1.18 in the x axis, and the delta time, which was 0.033 seconds, basically the interval between each data point. For the second part of our code in our computational model, the key thing to figure out was our formulas. In this case, we wanted to know our object's velocity and its position in each of time, in this case, our delta time. So to do this, we just had to input our velocity update formula and our position update formula to update accordingly. Another thing to note is that we had to make sure that the time was the same as the one in our observational video so the comparisons would match in the final plot. So, after finally obtaining all of our data necessary from our experimental observation generated by our motion tracker and all of our information generated by our computational model that created data points from the code, I was finally capable of generating an Excel sheet with all the data points. So, as you can see in this case, the time is being showcased in the x axis and the position is being showcased in the y axis. The blue data points that you can observe are from our experimental data, and our red data points that you can see are from our computational model. So, based on this visualized information, we can see that the motion of both is pretty much the same, following the same upwards line. The main difference being is that the line from our experimental data points are slightly lower than that from our computational data. So, my main guess for this is that there is actually friction in real life that might be influencing the behavior of our experiment, whereas in our computational model, it was assumed that the net force was 0 and the friction was 0 as well. So, that can be one reasoning as to why there is a slight difference between both experiments. So that was it for our experiment, but some follow up questions that we can have are: what if the axes on our motion tracker were flipped? Well, in this case, it wouldn't really change the results, it would just change the way that we visually see the information. In this case, we have an upward slope, and changing the axis will just convert this into a downward slope. And is it possible for me to know all the forces acting together to get the net force? The answer is no, we cannot really know. But based on this experiment, we can assume that there is probably some friction and maybe some air resistance that is most likely acting in our ball. And that was lab one. Thank you.